All right, lively bunch here after lunch. Thanks for coming. Appreciate you coming to join our session and hear about modernizing legacy and enterprise applications through cloud-native solutions on AWS. I'm Doug Bourgeois with Deloitte Consulting. I lead our cloud computing business for the federal market. Immediately to my left, to your right, Scott Buchholz, who is managing director in our technology, strategy, and architecture practice, and is also, our SI practice, systems engineering practice, and in systems integration, and is also our CTO for the federal consulting practice is here. And Steve Lebo, an IT architect with Amtrak, one of our key clients, and we're really thrilled to have him here to talk about what he's been able to do and with his team and with respect to serverless computing, which, interestingly enough, I think those of you that went to the keynote with Werner, how many of you saw that? You hear him talk about serverless architectures? All right, here you go. Right, so we're already there doing that in the federal space. But before we jump in, and I turn it over to the two panel members to kind of talk about the problem that they solved, obviously, with respect to cloud computing in the federal space and AWS, Deloitte has been really in the thick of things, helping our clients adopt and migrate to and integrate with AWS services. Some of our key areas of the practice include planning and executing cloud migrations, doing some deep engineering analysis around the workloads or the entire data center and helping prep for those migrations. Helping to our clients to address some of the challenges associated with managing multi-cloud environments, helping our clients assess and manage the risks associated with not only adopting the cloud, but migrating to the cloud and managing that risk from a holistic perspective. And then we're also making investments in some emerging technologies. Also some of the things that Werner was talking about, particularly around IoT and machine learning and cognitive computing and how to leverage the capabilities of AWS services in the cloud in order to deliver those capabilities. So from that vantage point, we also have one other offering I didn't mention, and that's cloud-native applications, right? So we're helping our clients architect, build, and deploy and manage applications in the cloud that are native, meaning that they can take advantage of advanced architectures and services such as serverless architectures. And with that, I will turn it over to Scott and Steve to talk about the Amtrak use case and success story.
Sure. Just quickly, want to apologize a little bit in advance. We've been having some fun with slides of late, so we had a couple of little hiccups, and we don't have all the slides we wanted to show you, all 3,000 of them. So we're really sorry. There are a couple we'll probably describe rather than show, but we should get through it. Steve, do you want to talk a little bit about Amtrak?
You can see on screen some of the key characteristics of Amtrak, also known as the National Railroad Passenger Corporation. I apologize a little bit. I was told yesterday I was going to have to talk, so I'm going to do all this on the fly. But what I'm really going to say here is that when Deloitte was brought in, it was to design a system that did not require any servers to be stood up. That was one of the mandates I gave them. I also wanted to design a system that didn't require waiting for a DBA to do something in 3 weeks, waiting for a schema to be designed, which usually takes 6 months, and as you know, after 6 months, it has to be redone again, and probably in another 6 months, it's done again. So the goal here was to design a system that was entirely flexible to the data formats that were coming in. And the data formats in this case, for you to understand, are our passenger name records and our ticketing information. So as tickets are developed in our TPF mainframe, they flow out immediately, and we capture those in real time now, which we've never done before. And we push them to the cloud. This allowed us to actually start looking at data in near real time. So when we talk to our marketing folks, what is near real time? How fast is a train selling out? We sell trains 334 days into the future. So near real time for our travelers, though, because we're not like the airlines, is the day before. Most people don't book a Northeast trip until 2 to 3 days before they're actually ready to leave or on the day of. So this was a goal of trying to find out that information as quickly as possible. So that was the start of the task that Deloitte was asked to do.
And we spent a lot of time working with Steve and Scott Henderson, who was the chief architect at the time and has since retired, in terms of helping them implement the vision that they had come up with. If you look at the screen, there are a few of the things that we were trying to address in terms of objectives. So the first one was inconsistent response time. We put together, let's loosely call it, a platform as a service-based analytics solution that's designed to provide operational reporting and information as well as analytical reporting and information for both Amtrak operations, who's on the train, how many people are on the train, those sorts of questions, as well as sales and marketing purposes, how much have we sold out, what does inventory look like, what does pricing look like, those sorts of pieces of information.
So another real-time bit of information for you is who is on our train. We do not have gate control like the airlines. You can get on a train at most locations just by walking onto a train. So to answer to the National Transportation Safety Board or anybody else after an accident, who was on our train, we have to have lift data that we now do using an iPhone to scan your ticket. That data is immediately processed. And again, it was something else. I needed to get into this system, so when somebody says, show me who is on this train right now, I had to take off the people who had already disembarked at earlier stops and be able to tell them these are the people left on the train. Again, another near real-time analytics that I needed to have in place for this.
And so as you were looking at these challenges here, trying to decide how you were going to approach resolving those challenges, was there any one in particular, or what led you to look at serverless architecture as the answer to these challenges?
For me, I think I started off by saying I didn't want to have to wait for servers to be stood up in a data center. Even though we went to virtualizing our servers many years ago, it could still take 6 months from the time you asked for it to the time you actually could log into it. Again, being able to go to the cloud, I still didn't want servers because they took the data center model and just moved it to the Amazon cloud. You still had to ask for a server, you still had to explain why you wanted it, what's the capacity, et cetera, et cetera. I didn't want to do that anymore. Having done it for about 17 years, I really want it almost easy. DynamoDB is already there. It handles the scaling for you. You just have to create your tables. Of course, they stopped us at that point, saying they needed to put stuff in place. You just couldn't willy-nilly create tables. But until we got caught, we accomplished a lot until we got slowed down by the usual, are you following all the change process, et cetera, et cetera. But that was one of the goals. Using Lambda was another one. And eventually, once we needed to do this near real-time reporting, I needed to move it into Redshift. And again, that's something that I don't have to worry about. We set it up. Yes, you do need a DB at that point, but it's actually fairly simple, nice columnar database, and you don't have to worry too much about the schema at that point.
So those are good reasons. At first, I thought you were going to say, we've all heard of server huggers, that you are the anti-server hugger pattern, but no, that's not it. You actually had some other compelling reasons to do that. Okay.
Yeah, when we started working with Steve, it was clear, for all the reasons that Steve clearly articulated, that the right answer was to look at some of the Amazon managed data services. We looked at the relational options, we looked at the non-relational options, we looked at the analytical options, and we went through, and under Steve's guidance, and with Steve's help, we wound up selecting DynamoDB. And that was for a couple different reasons. One was because it worked really well with the Lambda functions and some of the other data pipeline functions that we wanted to be able to use to get data into the database, into the system, and then downstream from there for other purposes. The second reason was because, oddly enough, the ticketing data is not in a consistent format and structure all the time every single time, or at least different ticket types have very different formats. And it was really nice to be able to use some of the flexibility of the NoSQL databases to not have to have an enforced schema in order to get things done.
That is true. We have never been able to design a database to hold all our ticketing information because a lot of tickets simply don't match up with a ticket created by a travel agent versus a ticket created from a quick track machine. We have started to standardize a lot of that in the last couple of years, but we did run into those issues on how do I store data that's really different. To give you an example, you can buy a multi-ride ticket. Well, that means you can go from this origin to this destination, but I don't know when. And that ticket is very different than a single ride ticket from here to New York. Very different from somebody who's going to buy a US rail pass that allows them to travel amongst the cities in this country, 18 trips on a fixed price. Again, that data is very different than a standard ticket model that you might see.
Where we started was by doing some analysis of the existing systems and the options. So a lot of things going into this. There were a couple of databases that did together much of the job that was needed. Not necessarily all of the job that was needed all the time, and there were a couple of them, not a single one. And so one of our design objectives for the solution was to actually try to go through and figure out how to do this all in one spot, all in a consolidated place, and somewhere that we knew would be able to perform. So if you were to look at, for example, some of the existing queries and some of the existing databases that were the legacy systems in this case, as it was mentioned on the previous slide, they could take seconds to hours, or at least long sets of minutes, to respond to common queries. And the problem was you could never tell what the query time would be this time through. And that was a real problem if you think about some of the use cases Steve was talking about at the beginning. If there's a train crash, heaven forbid, right, then you need to know who was on the train as quickly as humanly possible. Well, if you're running the query and you're not really sure when it's going to return to you, that's not actually an optimal outcome. We went through and looked at a whole bunch of different options that are listed up here in terms of design patterns to fix the problem. And some of these design patterns have to do with changing existing systems. Some of them had to do with modifying ones and enhancing in others. And to make a long story short, where we wound up with was, as Steve was describing earlier, the serverless solution in the cloud, certainly as a prototype and a paradigm for how we were going to move forward, as well as the NoSQL option for the operational storage. And that, again, had a lot to do with the ability to operate without a schema in an environment where there were lots of different data formats.
So we have been working with Amazon for the last 4 years. We've been a client of them for a while. I will point out on this slide, DynamoDB is not my first choice. I could do better with Mongo. I can actually do better with Couchbase. But neither one of them offered me a serverless environment, completely managed service. So we did stress that on top of some other criteria, which is the ability to query multiple indexes, which you know with DynamoDB, yes, you get your 5 globals, you can have the 5 locals, you got your primary key, but that does limit your ability to actually query into the database, especially when I have a customer on the phone and they want to say, you say, what's your ticket number? I don't know. What's your PNR number? I don't know. What's your last name? Well, I'm going to have to look you up by your last name. What's your email address? What's your phone number? I need to have some bit of information from you to know I'm actually talking to the right person. So DynamoDB wasn't our first choice, but it was the one we settled on for the reasons of a completely managed service in the cloud by AWS.
Okay. Actually, Steve. So by the way, what's really great about Steve and is that when we work with the folks from AWS, they're impressed by how much Steve knows. So I don't know if they tell you that, they tell us that. So,
They don't tell me that.
so they're always impressed by how much Steve actually knows about their products. So I'm happy to describe this, Steve, or you're welcome to talk a little bit about
I'll
it.
let you go ahead on this one. So, are you okay with this slide?
I'm okay with this slide,
Let's
Steve.
go.
So Lambda Code, as many of you probably know, in AWS is little pieces of serverless code, or little pieces of code that don't require you to manage a server instance in order to run and execute. And Lambda Code can do all sorts of different things. So you can establish web services that use Lambda Code to access and update information. You can use Lambda Code to react to events like data being uploaded into a database in order to, in our case, move it downstream to the downstream systems. You can use Lambda functions to do all sorts of different things. Because what we were trying to do was primarily get data out of the mainframe, where it was very difficult to get access to, into DynamoDB, so that we could run queries and do things, scrub the operational information that we needed. So if you think about it, there's one Dynamo database that has a lot of history in it. There's another Dynamo database that happens to have a lot of the operational stuff. So that's basically everything 7 days ago and into the future. And the reason we did that was so that we could have predictable performance. We didn't want to have to scan every record for the history of time in order to be able to tell you who was on the train today. Right?
Another reason that Lambda came in very helpful was we run a TPF, IBM transaction processing facility mainframe, and it's designed for hundreds of thousands of messages per second. But what it doesn't do on the output is give me the records in any order. So I could get a ticket before I actually got my PNR. PNR is just another term that you've heard in the airline industry for your passenger name record. It's that silly 6-character alphanumeric number that you see, which in truth, just to let you know, is just a mainframe memory location. If you ever wanted to know what that 6 digits was. As those tickets and PNRs are coming out, I have to match your PNR with your tickets. And they're not coming out in order. So one of the nice things that the guys were able to design was, as we're getting that history, we're able to know, well, this record has just been updated. This record has just been updated 30 seconds ago. And now I get the latest record out of my history table into my other tables. The history table does contain every record that the mainframe puts out, so marketing can know that you changed your mind, you changed this, they kind of know what your patterns are as you're buying your stuff. And that was, Lambda was very good at, because as a record hits, DynamoDB, it immediately goes into the stream. It calls you. You now know this is the latest record. You know how to update the system. In this case, we use Kinesis so that we could have a lot more shards running against the Lambda functions. And that's why you see Kinesis as part of this solution.
So, and as Steve mentioned, by the way, there are people who, for whatever reason, in the middle of the night, change their minds 100 times or more in terms of which train they're going to be taking. Should you be one of those people, all of your records are stored for you. So we're more than happy to have a discussion with those of you who can't make up your minds about what's going on.
So how difficult, in terms of, it was just, I assume, the first time you used Lambda. How difficult was it for, to adopt, and were there any challenges that you ran into in terms of, how is it really as easy to
it's
use?
It's as easy to use as Amazon makes it out, especially if you're a Java programmer, but they have Node.js, they've added another C#, probably another few other languages to it. It was very simple. It calls you, you know what the record type is going to look like, you decide what the records are going to be, the old record, the new record, or both. And it gives you the opportunity to modify the data before you stick it into another table. In this case, we created tables for very specific uses. A segment table was designed because you can ask for a ride on a train but not pay for it. So therefore, I have your PNR record, but you have no ticket associated with it. I needed to know that because if I have to cancel a train or something happens, I have to be able to notify you. So I had to have that record. At the same time, I need to know who was ticketed for that train. And then I need to know of those people who were ticketed, did they really get on that train? And I only know that as the conductor scanned those records. In the past, as you might have remembered, you got a ticket, there was a conductor, he had a nice little punch, he punched your ticket, he took one part of it, that went into a pouch to El Paso, Texas to get scanned, and that's when I could realize the revenue, and then you got back the other part of the ticket. A little bit of trivia, every conductor had his own punch symbol. So if anything ever went wrong, you could actually look at the symbol of the punch and you knew which conductor actually punched that ticket. This way, I actually have all the lifted data in the system, as I said, to be able to run a manifest report. That's the most important thing. Run a manifest report for me and tell me who is on this train. An airline knows who was on the flight. You went through gate control, you all got loaded, you all got scanned. I don't have that flexibility at all. I don't know, as I said, who's on that. Anything else?
In terms of being serverless, I mean, in the past with previous architectures, with the server, we know how to secure it, we know how to operate it. Does using something like Lambda require a change in the way we approach either security or operations?
Security was tough because of the way we were set up. In DynamoDB, there is no such thing as put it in a test environment, put it in a stage environment, in a production environment. With DynamoDB, it's just a service. You have to design your own schema around how are you going to have a dev, test, stage, and prod environment. And that just came around, how do you name your tables and how do you do all your tagging? And once you had that, then you can just use Amazon's IMA to control access to each one of those tables. And that's how we had to do it. Again, depending on how you set up your AWS as your organization, you can control access by having multiple accounts, or you have a single account where you sort of control access through the command line. In this case, we had a single account, which meant all access was through the command line, never through the console. So that does bring a little bit of problems when you're trying to work with the system, but we overcame that to be able to set this up.
So, and there were a couple, as Steve mentioned, organizational challenges in terms of working with a single account, but that was sort of a choice that the infrastructure team had made. I would also offer that from a security perspective, there was a certain amount of anxiety on the part of people who hadn't gone on the journey with Steve and Scott for the design of the system, because frankly, they didn't know the system particularly well. They didn't understand it. The concept of things being done for you in a managed fashion and not having servers to manage that they were comfortable, that they knew how to secure, generated a certain amount of anxiety for a number of people in the IT organization. Right? Not only because from a maintenance O&M perspective, there were people who had no idea what their jobs were supposed to be because there wasn't a database to tune. The list of things that they didn't have to do that they were accustomed to doing, they didn't sort of know what to do with. That was one challenge. And then there was another sort of personal challenge, which is some of the people in the organization weren't comfortable that a system that they couldn't see and touch, that wasn't comfortably within the bounds of what everybody knew, running on a server in a known spot, was something that they could get their arms around or get their heads around being secure. So I would say that it was as much a technical journey as it was an organizational journey in many ways.
I echo that. The technical part was very easy. The operational side of this took a lot longer because they were like, well, how am I monitoring to this? Well, no, Amazon monitors this for you. Well, how do I know there's an error in the system? Well, we'll send out alerts when there's an error in the system. How do I do this? How do I do this? And we probably spent 6 months on just trying to get it into production in an operational mode. Once you overcome those hurdles, though, at your organization, and the next project becomes a lot easier, and the next project becomes a lot easier. This was the first project that we had ever done in a sort of managed services in AWS. Everything that we had done before was just a standard server. What was the EC2 instance? Who's going to have login to it, et cetera, et cetera. They were like, well, how do I log into Lambda? Well, you don't really log into it. So we had to overcome those ideas of the old way versus the new way. I'm going to retire, and I wanted to retire on doing nothing but the new way because I was very sick of the old way after X number of years.
Okay. And by the way, I probably should have mentioned, from start to going live, it took us 6 months?
6 months.
So from conception and initial development to going live in production was about 6 months. The system's been live since January, and it's basically been, I won't say it's been ignored, because it hasn't really been ignored, but it's been kind of running quietly in the background, doing its job, ever since it went live, without a whole lot of excitement, with the exception of the S3 outage. What was really exciting about the S3 outage, by the way, is that we learned that the SNS system that we were using to send email alerts
Didn't work.
was built on S3. And we also learned that our respective email servers and services did not appreciate us receiving 18,000 email when S3 came back online. So,
But I will point out that by being able to decouple a lot of systems here and using Kinesis meant that I could go back to S3, pull the data out, or one of the things that we really wanted to do was always store history. That's very different than you're used to in a normal database environment. You always change your data, you stick it in the database. You never know what the history looked like. In this case, as it comes out of the mainframe, we don't change it except to put it in a JSON format, and we store it. We had the ability now to go back and just replay all of those records that didn't get put into S3, that did not get moved into Redshift. A nice decoupling that you just don't used to have in the past.
So with that strong performance, how is this architected?
well, so this was value delivered. I don't know. So how's this? I don't know that I would believe some of the cost numbers on this slide. I don't think they were supposed to be there. Let me say this, right? It was probably based on a month that somebody pulled a random set of information, and it's a little bit like Excel. You can play back a formula, and it generates a number, and sometimes it actually means something. But think of the costs. We've seen the costs. They're a little bit like your monthly electricity bill. Some months they're a little higher. Some months they're a little lower. But as a general rule, you know what they look like. There's sometimes a seasonality to them. And the overall costs of running the system have been, we believe, dramatically less than what it has been to run the legacy systems that it's been replacing.
So the legacy systems, the reason Scott was mentioning this, we actually run fairly hot. It was that we had to take 5 years worth of data out of an Oracle database. I had to get data out of DB2. I had to get data out of an SQL database and convert it now from a schema of a relational and put it into a non-relational JSON format. That has taken probably about 6 months from start to finish. The job just runs 24 hours a day, pulling out records out of the old system, creates a Cartesian join, always fun, and has to then dedupe all those records down to the final record that I need to put into the system. So one of the things to be able to retire at least 5 old database systems was to move that data. And that's one of been the biggest challenges too, is how do you get data out of really old systems that have been around? Most people don't even remember DB2. Maybe you remember Informix. These database systems have been around for many years. A company like Amtrak has at one time owned every single one of them from Sybase. In fact, our very first booking system was built on an Informix database.
Okay. The system has been very successful at what it was designed to do. So it was designed to essentially be the extract of information out of the mainframe system so that people could use it, consume it in a loosely coupled way, as Steve mentioned. The legacy systems were set up in ways where everybody had their hands down everybody else's system's pants, and it was very difficult to change anything at all without numerous people screaming. So that's been streamlined. There are also, I think it's the next slide, one of the things that we were able to do, in addition, was to actually use Tableau and start building dashboards on top of the data. So sort of a couple of, and maybe I'll do sort of the quick architecture picture up here with my hands. So I apologize, in our little slide shuffle, we lost the architecture picture slide. But if you think about it, you have the mainframe that's generating information, ticket data, passenger data. It goes into DynamoDB. Right, so it basically makes its way into DynamoDB, and it goes into the history store, so the historical store in Dynamo. There are a series of Lambda functions that move from there to what we call the operational store, which is the latest version of recent records, that then are accessible through MuleSoft APIs when you want to get recent records and other things. So one of the design decisions was we didn't want people accessing the data directly. We wanted them to go through web services in order to be able to get to it, so that we didn't wind up with the problem of cross-joined queries across database links as we did have in some of the legacy systems. And then some of the Lambda functions then took the data out of the operational store and would feed it downstream to a Redshift instance. So the Redshift instance, when we started, was an experiment.
No, it was always planned.
It was always planned?
Always planned to be part of
It
the
was not
system.
described that way to me by the team, but whatever. Steve always had the plan, regardless.
Actually, I'll correct myself. We really wanted to use DynamoDB for everything, but you find out the limitations of being able to query it. And so we had to go looking for something else to be able to run all these queries. One of the first things we encountered when we set up this system is, when can I write a query against DynamoDB? Everybody, of course, always wants to query your database. And we're like, you're never going to query this database. You are going to talk to, in our case, we use a product that abstracts all access to data away from you. You call the APIs, we'll give you back the data. That was the first hurdle we had to overcome when people are so used to getting to the data. We were intending to use a couple of products that Amazon was releasing to query the data, but it turned out that Amazon required you to move all of that data into their querying product. I'm trying to remember the name of it. I think it's QuickSight. Or they developed a new one called Athena, which you can now use. We back up all our data. Even though DynamoDB is highly resilient, it was a recommendation from AWS that any data you put in a DynamoDB database, you back up into S3. And so all our data is backed up to S3. And now with Athena, you can actually run queries against data in S3 if you want to. The Redshift was there to allow us to query on trains. I want to know this train, it's leaving Chicago, how many people are on it. I got 3 trains at one time on the tracks. The train that left 2 days ago, the train that left a day ago, and the train that's leaving today. It takes 3.5 days to go from Chicago to Seattle. Our longest journey is around, depending, could be as much as 4 days. If you really want to just sightsee the country, it can take you 4 days on a particular journey, including buses.
Sounds like that calculus problem I was helping my son with the other day.
It is. Anyway, so as I was saying, mainframe, Dynamo, Redshift. The Redshift instance was what we were making available to the sales and marketing team so that they could start doing dashboards and getting the information that they were really after, which was much more customer focused, much more revenue focused, much more inventory focused. And if you what we were able to do was actually figure out a frequency with which we were going to get data into Redshift so that they could load it. And one of the things that we discovered was that it's actually, we set it up so that you can, in some ways, dial up and dial down the frequency of loads, depending on what it was that people needed. And if you think about that for just a moment, what you realize is the more often you're loading data into your analytics store, the more you're going to wind up paying, because you're consuming CPU and other resources, and Amazon will charge you for them, justifiably. But in essence, if you work with your business users at that point, you have a range that you can say, if it's more important to you to get the data quicker, there are more expensive ways of getting it to you. So then the question that you can start having is, what is the value of data frequency? What is the value of data currency in your dashboards? To Steve's point, if people are only buying tickets 2 or 3 days in advance, maybe 24 hours is enough, and maybe you can save money in that way if you're making it at that frequency. The sales and marketing group wanted things that were more current than that, so it's set closer to an hour, right? But there is a range of options, and one of the wonderful things about working in a serverless environment is suddenly you have the ability to move things around in ways that you didn't before, or in ways that were much more difficult before.
So another advantage of this system was to backfeed in revenue management system. So you're all aware of, if you buy early on an airline, the price is cheaper. We're no different. We have our YA buckets, our YB buckets, and it's always how many seats do I put in each bucket? Each bucket has a price, and now I'm actually to send data back as fast as possible so that you can, the marketing folks can adjust the demand on buckets. I'll also put in another plug, I'll put a plug in for Dynamo. One of the things that I knew that in selecting Dynamo, even though it wasn't the best, was that Amazon never stands still. And some of the things that we had to overcome are now being fixed by Amazon. Time to live on data, now it goes. I don't have to go back in the database, figure out the data is old, I need to get rid of it. Adjusting your read-write queries. We are hot during the day. We book from 5 a.m. to 9 at night. The rest of the time we sit idle. Because the country is asleep, nobody's really booking tickets overseas. So being able to go down and back up again on a schedule is something that's really nice to be able to do, because it's a very good cost savings. Before, if you're just running servers, you're paying for it 24 hours a day, 7 days a week, and you have no way of adjusting that. Here we do have a way of adjusting how we use the system.
And one thing that really stands out from the visualizations here is that it looks like we're able to leverage the visualization layer to tune the technology to really provide business value to the business users, and enable them to make decisions in the manner that they want to make decisions. And so it's a combination of the business capability and the technology, and the two working together to actually solve a business problem. And I think that's pretty interesting, rather than just the operational visualizations that we tend to get out of these types of technologies, and contrasting the business value and leveraging that with this architecture. In the interest of time, I know we do have more content we can go to, but I thought we'd open it up for questions now, and see if anyone in the audience has a question for our panel here. And we have a couple over here.
Amtrak.com is just one channel that feeds the system. So it's a mainframe booking system that Amtrak.com, your mobile app, your kiosks at the station agents, call centers, travel agents, Expedia. There are probably 10 or 15 different ways that you can book a ticket on our system.
There's another question back here.
That was a harder one for us to solve, and one that I wish Amazon would solve for me. Because we had to encrypt the data as we are putting it, before we put it in the DynamoDB, because I do have PII requirements. I have no PCI requirements, because I don't store your credit card, I never want to, I don't want to be in that business. And I then have to decrypt it. That means that, where do I store these keys? Well, we thought we would store them in the key storage area of Amazon. you can't do it. So we had to have our own key store, and security is not top-notch because it's kind of hard-coded somewhere. And you have to go get that key to decrypt the data when you pull the data out and send it to a downstream system. I have state partners. I have to send state partners. How many people got on this train in your state? We get money from states to run trains. So therefore, we have to, if you get on in Virginia, I give you all that ticket money in Virginia. If you get off in Virginia, I give you all that ticket money in Virginia. Because Virginia is paying for us to stop trains in that state instead of going through it. So again, it was a little hard to try and get data to our state partners in terms of I always have to decrypt it when I send it, because they want to know who's buying the tickets, et cetera.
More questions? I've got one over here. Let's, in the interest of time here.
This was an Agile project. It was one of the first that we have done that was successful. We were taking over a failed project that had spent 2 years trying to do the exact same thing that we actually accomplished in 6 months. And that really goes to the Deloitte team. I will put a plug in for Deloitte, that we were able to carry this off in such a short period of time. And again, it was serverless architecture. There's a lot of time, as you know, in a project, just getting all the infrastructure stood up. In this case, you didn't have to do any of that.
There's one back here in the back.
It depends on the move too. MongoDB indexes nearly everything for you. Dynamo doesn't, as I said. That was my biggest heartache of moving, because then I can't query this row for something. And I needed to query on 15 different fields. Well, Dynamo doesn't provide you 15 different fields. And of course, as you know, every global secondary index you create creates another copy of the data in the system. And so now all of a sudden your data is being replicated. That was our biggest challenge, I think, making the move. What I like about it, though, is it's flexible. So that this ticket record looks this long. This ticket record is a group ticket. I got 19 people traveling. So I got to have all their names in the system. Before, you'd have to create indexes over here, a one-to-many relationship, and you're looking at somewhere around 50 tables that were designed for the original system. I've got 3 tables, histories, and some other tables that we have created for queries into the system.
We might have time for one more.
Just to add on to the security question I was asking, for other federal agencies who are looking to ramp on to such a system for serverless architecture, what are some of the lessons learned from an ATO process, especially since this is highly secure data, or I would say FISMA moderate at least?
Well, I'll answer that question. We are not FedRAMP. We do not have to meet any of the FedRAMP requirements. While we are supported by the federal government and we are a quasi-federal agency, we are certainly monitored by the FRA and everything we do. In this case, we were able to just go to a standard AWS setup in US East. That's where we are. We are expanding to the west, and we will do that at some point. One of the new systems that we are standing up will require a West Coast, East Coast, and that has to do with meeting the requirement for positive train control. And that will actually be running out of AWS for us.
What I would observe, though, is there was actually a lot of prototyping and experimenting and other things. It wasn't necessarily clear at the very beginning of the project what the answers were going to be to all the questions. So we spent a bunch of time learning and trying things, and then in some cases backtracking and trying other things during that 6-month time that we talked about in order to get to the solution that we have today. And as Steve mentioned, we didn't have to spend as much time on security and ATO processes. We did have to do a lot of work to make sure that things were secure. And what I would observe is We as Deloitte have been doing some internal prototyping and other things so that we have accelerators ready to help people do that. And one of the things that we've been thinking about as well is, are there ways of accelerating security for federal organizations, not just the more commercial-minded ones?
On that note, please go into your AWS app and complete your survey on the session and be positive for our great panel members. Thanks. Please give them a round of applause for their insights for you, and thank you all for coming again.